Alright lads, it's Danny here today bringing you a lovely video. In today's video we're going to take a look at the derivative of the absolute value of x. What is that equal to, right? Before we jump into it, I want you to leave a like and subscribe. So before we do anything and before we prove the absolute value, the derivative of the absolute value of x, you are going to need to apply the limit definition from calculus 1. It's given by this formula right before you. The next step afterwards is we are going to need to rewrite the absolute value. We got to find an equivalent expression to the absolute value of x. And you know, basically the equivalent expression I'm looking for is absolute value of x can be rewritten as square root x squared. Think about it. If you have any negative number squared and then square root, it's always going to yield a positive answer. And that's what the absolute value of x is always going to yield a positive answer. So therefore you can rewrite it with square root x squared, and we are going to solve for square root of x squared instead. Therefore we can basically take the derivative of the absolute value of x is equal to the derivative of the square root x squared. Now we can apply the limit definition when it's written in this format. So applying the limit definition, we can rewrite the equation as follows. From here, we are basically going to try to eliminate and simplify. And the way we have to do this is that we need to introduce a fraction to basically do a difference of sums in the numerator, and just it's going to be a lot easier to isolate and simplify. So by doing so, we are going to basically multiply an additional fraction, you know, as you can see right before you. In the numerator and in the denominator, they are equivalent. So when you divide them, it's basically equal to 1. And the reason for it, as I mentioned, we are going to do a difference of sums in the numerator. So we can rewrite these two fractions into 1 by multiplying it. And what you are going to have is this. And notice the square roots basically disappear in the numerator. And that's the idea over here. We want to eliminate that square root. It's very difficult to simplify and solve when you got a square root in the numerator. So we are then going to decide to basically expand x plus h squared. We are going to expand that bracket. And what you are going to have is this limit when you rewrite it. Notice we can easily simplify some like terms over here. X squared and minus x squared is going to cancel out. And in the numerator, it can be written as the limit as h approaches 0 of this numerator and of this denominator. But we can go a step further and remove the h term that shows up in the numerator and the denominator. Notice the two terms in the numerator both contain an h term basically, so that we can factor out an h. And when we do that, they basically cancel out. So what you are going to be left with is this limit, and this is the time where you are going to apply the limit and you're going to solve for it. So when we apply the limit, the h's are going to disappear, and what you are going to have is this expression before you. 2x divided by 2 square root of x squared. Notice there's a 2 that shows up in the numerator and 1 that shows up in the denominator. We can then rewrite it once more as x divided by square root of x squared. As I mentioned to you at the beginning of this video, we can denote square root of x squared as the absolute value of x. So therefore we are going to replace it with the absolute value of x, and there you have it. So what I'm trying to show you lot is that the derivative of the absolute value of x is actually equal to x divided by the absolute value of x. So if you lot enjoyed this video, please drop a like and subscribe, and I'll see you lot later.